I hope all of you are doing good. Let's start today's chapter, data handling. After reading this chapter, you will be able to know about all these topics. Okay, so let's get started. Introduction. In our earlier class, we have learned about data, collection of data, its organization in the form of tabulation, bar graphs. The presentation of data helps us to draw inference from them. Now we will learn to organize the data and present it in such a way that it helps us to draw many inferences from it. For example, if we collect the data about the height of students in class and present them as it is, it may not be of much use. But if we arrange and tabulate them properly, we may come to know about average height of the students, maximum and minimum height of the students in the class, etc. Data. Data is a collection of numbers to gather some information. For example, collection of age of the students in a class, collection of income of the people in a locality, etc. Remember, data is a plural word. A single numeric is never termed as data, it is data, right? Now let's learn about type of data. There are two types of data. Number one, primary data, and number two, secondary data. Primary data. What is primary data? Data collected by a person for himself or for someone else is called primary data. For example, there can be data about height of students studying in various sections of class 7, or there can be data about the size of the shoes used by the students of class 7, etc. Number two, secondary data. The data collected by someone when used by someone else is called secondary data. For example, as done in one above, a shoe company can use the data to decide most common shoe size for a particular age group. Okay. Now, collection of data. Before collecting any data, we must know the purpose of collecting data, relevance of collected data for the purpose. The data collected must be specific and complete for the purpose. Try to collect the data for the following situations. Performance of Indian cricket team in the ICC World Cup 2019. Number of children below age of 10 years in your locality, and performance of your class in English in the first assessment. You should first find out what kind of data is needed for the situation. What will be the source of the data and in what form you will be collecting the required data. Unless the data is appropriate for the purpose, it is of no use for us. Okay. Now let's find out how to organize data, that is organization of data. Raw data, the data collected and put without any specific arrangement is called raw data. Each entry in a raw data is called an observation. When we collect data, we need to record it and then organize it. A raw data is not suitable to draw inferences. Thus, its organization is necessary. Let us see the following example. Suppose you have collected marks obtained by the students of your group in English out of 100 and you write it in the following manner. Okay, see, these are the numbers or marks obtained by the students. Okay, it is not easy to understand such data, but if we arrange them in ascending or descending order, we may draw many conclusions about the group members. Okay, so now we have arranged this data in ascending order. Inference which can be drawn now from this order may be summarized as, see, it is in ascending order. So clearly you can see that 10 is the lowest mark and 92 is the highest mark. Okay. So the highest mark scored by a member of the group is 92. The minimum marks obtained by a group member is 10. And there are 4 students getting marks less than 45, means 1, 2, 3, 4. These 4 marks are less than 45. So there are 4 students who are getting less than 45 marks. And number of students getting marks more than 70, 1, 2, 3. So there are other ways also to organize the data, such as in the form of table with the name of the students. Okay. Next, representative values of data. We have heard about average temperature of a place, average marks obtained by a student in the class, average age of the students in a class, average hours spent by a class, 7 students in studying. Here by average we mean usually, thus average temperature of a place is 35 degrees Celsius, means very often the temperature is around 35 degrees Celsius. So average is that number which represents the data as a whole in terms of a single value. It shows the central tendency of the data collected. So when we say average height of the students of class 7 is 5 feet, we mean that most of the students of class 7 have height around 5 feet. Maybe a little less or little more. There are three forms of measure of central tendency of the group of data. They are mean, okay, median and mode. Mean is also termed as arithmetic mean. Okay, so first we learn about arithmetic mean. It is the most common representative value of a group of data. To calculate arithmetic mean, we divide the sum of all the observations by the number of observations. Arithmetic means is equals to sum of all observations upon number of observations. Let us solve a few examples to understand this, but first, no more. In statistics, for total sum, sometimes this sign, which is also known as sigma, is used. It means summation, okay? Example, the runs scored by a batsman in 6 one-day matches are given below, okay? So, these are the runs which he scored in 6 one-day matches. Calculate the mean runs scored by him in the 6 one-day matches, okay? So, you have to find out the arithmetic mean. What will you do? Sum of runs scored. Sum of runs scored upon number of matches played. Number of matches played. So, 25 plus 12 plus 45 plus 75 plus 63 plus 20. How many matches he played? 6 matches. Okay. So, total you will get 240 by 6 and then you will get 40 answer. Okay. So, mean run score is 40. Okay. Similarly, example 2 also, you will find out the mean hours of studies for Rashu if he studies for 5 hours. What will you do? Total studies are the number of days. Now, next, range. Range is defined as the difference between the highest and the lowest observation of the given data. It gives us an idea about the spread of data or group of observation. For example, the marks obtained by 10 students in exam mathematics out of 100 are given below. Okay, so these are the marks obtained by 10 students, right? Here the maximum marks are, as you can see, maximum marks are what? 93, and the minimum marks are what? 10. So the range, what will be the range? Range means highest minus lowest number. So 83 is the range. Also, if you have to find out the mean, then what will you do? You will add up all the numbers and then divide it by 10, because this is the data of what? 10 students. Okay. Let's do exercise 3.1. Organize the following marks in an assessment and mathematics in a tabular form. Also calculate the range of the data. Okay, so first you will write them up in ascending order. Okay, only then you can find out the range. Not only that, but you can find out it easily. Okay, so first arrange them in ascending order. So 1, okay, then 2, then 3, and there is one more 3, okay, then 4, one more 4 is there, then you have 5, then you have 6, then 7, then 8, then 9, okay. So clearly you can see that 1 is the lowest number and 9 is the highest number. So you have to find out the range. Range is equals to highest number minus lowest number. So 9 minus 1 is equals to 8. So this is the range, right? Median. Median, as the name suggests, is the middlemost value. Median is the value which is strictly in the middle of the list of the observations when written in ascending or descending order. It is also a measure of central tendency. Median is used to rank a certain number of observations for which data is collected. Let us now look at an example to understand median. Height of a group of students is given below. Okay, so these are the heights which are given in centimeter. To find the median first, we will arrange these observations in ascending order. Okay, now the total number of observations are 11 and the middlemost of these on arranging in ascending is 145. Therefore, the median height is 145. Okay, as you can see, 1, 2, 3, 4, 5. Okay, and 1, 2, 3, 4, 5. So this is this number which comes in the middle of these observations. So that is why 145 centimeter is the median height. Okay, no more. When the number of observation is odd, median is what? This is the formula, n plus 1 by 2, nth observation. Okay, and when the number of observation is even, median is average of n by 2 and n by 2 plus 1th observations. Okay, if any number is repeated in observation, then it will be written repeatedly in order. Example, in this case, see, as you can see, 2 is repeating, 3 has been repeated, 6 has been repeated. Okay, number of observations are 12 even, so the median will be average of 12 by 2th and 12 by 2 plus 1th time. So observation, so average of 6th and 7th observation is what? 3 plus 4 divided by 2 is 3.5. Okay, let's check out example 4. Find the median of the following observation. First, you will arrange this given data in ascending order. Okay, so after arranging in ascending order, we will get this. There are how many observations? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13, there are 13 observations. So 13 observation, and 13 is odd number. So the middlemost numbers, what is the formula? 13 by 2 plus 1, 1th term. So 13 plus 1 is 14 by 2. That is 7th observation. And 7th observation is what? 1, 2, 3, 4, 5, 6, 7, 8. So therefore median is 8. Okay, now mode. To understand the concept of mode, let us try to understand the following situation. Suppose a shoe manufacturer wants to find the size of shoes for different age groups. For this, he conducts a survey and collects the shoe sizes for a particular age group, say 13 years. Now, if he calculates the average shoe size for this age group, it may fit no one, because we have seen an earlier example. The mean may or may not be one of the given observations. Also, if he calculates median of the observations, it will fit only one, because half of the shoe sizes will be above the median and half will be below median. So neither the mean nor median is suitable in such situation. For such situation, the third measure of central tendency mode is applicable. Mode is the most common value of the given observation, or the value of the observation which is a repeated maximum number of times is the mode of the given data. So now if the shoe sizes for children of age 13 years collected by the shoe manufacturer are these. Okay, now it is clear that a size 4 is a repeated maximum number of times, so the mode is 4. It is also clear that a shoe size 4 will fit most of the children of age 13. So try to find more such situation where mode is the most appropriate means of central tendency. Okay, example 5. Find the mode of the numbers. Okay, see which number can you find here which has a which is repeated maximum number of times. So as we can see 3 is repeated maximum number of time. So the mode is 3, right? Let's do exercise 3.2. Find the median of the following. You have 14, 9, 15, 17, 8, 11, 13, 6, 16, 12 and 5. So first what will you do? First you will write them in, we will arrange them in ascending order. Okay, so which is the smallest number? 5, then 6, then you have this 8, then 9. Okay, then 11, 12, 13, 14, 15, 16, 17, 15, 16, 17. Okay, now count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 is an odd number. So what is the formula? 11 plus 1 by 2th term. So 11 plus 1 is 12. 12 by 2 is 6th term. Now find out which is the 6th term. 1, 2, 3, 4, 5, 6. Okay. So this is what? This is the median, right? Let's do exercise 3.3. In this case also you have to find out the median, like I did in exercise 3.2. First you will arrange them in ascending order, and then you will find out the median. Okay, you will apply here formula also if the observations are negative or positive, right? Bar graph. Use of bar graph for different purposes. Earlier class we have learned how to represent given data using pictograph and bar graph. First, the information is arranged in a frequency distribution table, and this information can be put as a visual representation in the form of pictograph or bar graph. Also, these bar graphs can be used to get more information, such as we can find range, mode, etc. Okay. Construction of bar graph. Bar graph is a representation of numbers using bars of uniform width, and length of the bars depend upon the frequency. The length is proportional to frequency. Remember, length is proportional to the frequency, okay, and depending upon the scale chosen. Let's look at the following example to understand the bar graph. Okay, so newspaper A, B, C, D given, and sales of newspapers is also given. Okay, so these are the sales of 5 newspapers in a city. So this is the bar graph. This is the x-axis. Okay, we have 2 axes. Okay, this is the x-axis and this is the y-axis. X-axis is also known as horizontal axis, and y-axis is also known as vertical axis. So here we will write newspaper, that is A, B, C, D and E, and here we will write number of newspapers. Okay, and this is how we plot the graph. Here scale has been chosen. 0.5 centimeter is equals to 100 newspapers. Okay, no more. In bar graph, selection of scale is very important. Sometimes along y-axis we use scale of 1 or 5 or 10 or 100 or 1000. It depends on highest frequency, right? And B, along x-axis normally we start with 0, but if lowest frequency is high and not possible to start with 0, then we do like this, like here is given. Okay, here line OX and OY are known as axis. Okay, the names of the newspaper are indicated along x-axis. This is the x-axis, and height proportion to the number of newspapers along y-axis. The widths of the bar are uniform. Uniform means same, and also the bars are at equal distances on x-axis. The following points must be remembered while drawing bar graph. Okay, so what are these points? First, it should have a title on the top of the graph. Number 2, the scale chosen to draw the bars must be indicated on the graph. Number 3, vertical and horizontal axes must be labeled. Number 4, bars should be drawn according to the scale indicated on the graph. 5, bars should be of equal width and should be at equal distance from each other. 6, the bars can be shaded or colored in order to give them distinct and attractive look. So it can be interpreted easily. Okay. In example 9 also, the following data gives the amount of wheat produced in 1000 tons during the year 2014 to 2020. So first you have to represent the above data with the help of a bar graph, and then with the help of bar graph find the year in which the production of wheat was maximum or minimum, and also find the difference between the maximum minimum production of wheat, that is range. Okay, so here is the bar graph. Okay, wheat production was maximum in which year? Clearly you can see in 2020, and wheat production was minimum in which year? 2014. Okay, and you have to find out the range. Range means maximum production minus minimum production. So maximum production is how much? See, 360 tons, and minimum production is how much? 200 tons. So you get here 160,000 tons. 1000 tons is the answer. This is your range. Now drawing double bar graphs. Bar graphs can also be used to compare data for 2 different situations. For example, it can be used to compare the performance of a child in 5 subjects in quarterly and half-yearly examination. Example 10, the following are the marks out of 100 obtained by a student in different subjects in 2 examinations, namely quarterly and half-yearly. Okay, so the data is given here. You have to represent this data using double bar graph and answer the following question. In which subject the performance of the student is same in 2 examinations? And B, in which subject the performance of the student in quarterly is better than half yearly? And number C, in which subject there is a maximum improvement in the performance of the student in half yearly as compared to quarterly examination? Let's check this out. First, we will draw a graph like this. Okay, here scale is 1 centimeter is equals to 10 marks. Okay. See, if the box is like you have 2 bars here, so this is quarterly, and half yearly we have taken horizontal lines. Okay. So here we have taken subject on x-axis, and y-axis we will write marks. So the performance of the students is the performance of students in 2 examinations. Okay. So performance of students was better in quarterly examination than half yearly examination. Which subject is this? So the subject is Hindi, because he performed better in quarterly examination as compared to half yearly, right? Okay. You have to find out the difference between the marks and mathematics. Okay, so mathematics, how much he marks got? 82 minus how much he got here? 63. Okay, so you will get the difference. And then in English 60 minus 50 is 10, and science 70 minus 63 is 5. It shows that maximum improvement in the performance of the student is mathematics. Okay, right? Clearly you can see from here. Let's do exercise 3.4. Read the bar graph given below and answer the question. See, on which item the expense is maximum? Maximum, you can see maximum expense is on food. So you will write food. B, on which 2 items the expenses are same? Here you can see these 2 are same. So you will write these here. And C, on which item the expense is minimum? Minimum is on what? This one. What is this? Clothing. Okay. Chances and probability. You all must have played a game of Ludo and snakes and ladder. I'm sure about that. In which you use a dice to find out any number out of 1 to 6 marked on 6 faces of the dice and play your move accordingly. Before throwing the dice, can you say with surety which number will turn up? Of course not. Only you guess about the number, which may or may not be true. Also, when we toss a coin, we never know which out of 2 possible outcomes, head and tail, will show up, right? So there are examples where we are not sure about the outcomes of performing an experiment. Definitions: experiment, an activity which yields or results into a single outcome, is called an experiment. For example, tossing a coin in experiment. So you will get either a tail or a head, right? Number 2, random experiment. An experiment which can be repeated a large number of times under the same conditions and the result is not predictable. It's called a random experiment. For example, tossing a coin 10 times in a random experiment, right? Trial. Performing an experiment is called a trial, okay? 4, outcome. The result of a single trial of an experiment is called outcome. For example, in tossing of a coin, getting a head or a tail are 2 possible outcomes. Number 5, event. 1 or more outcomes of an experiment. For example, in tossing of a coin, the possible outcomes, that is getting a head or getting a tail, is called an event. Given any situation such as throwing a dice, we need to find the chances of getting any one of the possible outcomes. In some cases, all possible outcomes have equal chances of occurrence, such as in tossing of an unbiased coin, both head and tail have equal chances of occurrence. There may be some cases when chances of occurrence of each possible outcomes are not the same. Suppose we have a dice such that the numbers on its top face in 6 attempts are unders. Okay. In this case, the chances of occurrence of numbers on the dice are not same. Of course, 1 and 2 have more chances of occurrence as compared to 3 or 4. So mathematically, probability is calculated using the following formula. So probability of any event A, that is PA, is equals to number of ways event A can occur and then upon the total number of possible outcomes. For example, when we toss a fair coin, there are 2 possible outcomes, namely head and tail. So therefore, probability of getting a head is calculated as number of ways which had occurred. Of course, it will occur only one time because there are only 2 possible outcomes. And there are total number of possible outcomes of tossing of a coin, 2. So probability is what? Probability of getting a head is 1 by 2. And probability of getting a tail is what? 1 by 2, right? No more. Number 1, sure event. If all the possible outcomes are favoring the event, then it is called sure event. Example, in tossing of a coin, getting either head or tail. Number 2, impossible event. If no elements favoring the event, it is called impossible event. Example, getting head on rolling a die. Can you get a head when you are rolling a die? Of course it is not possible. Or getting number 7 on rolling die, or when you are rolling a die, and there be any possibility to get a number 7? Of course not, because there are only 6 numbers, 1 to 6. So how can you get 7, right? Let's check out the example 11. A spinner has 8 sectors with the numbers 1 to 8 written on each sector. After spinning the spinner, what is the probability of getting a number of 3? Okay, so getting the probability of number 3 is what? Number of ways of getting 3 is only 1, and there are total outcomes 8, because there are 8 numbers 1 to 8. Now, probability of getting a number 8 is what? 1 by 8, right? Probability of getting number 4 is what? 1 by 8 only, right? Let's do exercise 3.5. Choose a number from 1 to 6. What is the probability of each outcome? What is the probability that the number chosen is an even number? What is the probability that the number is prime? Okay, so the numbers are 1, 2, 3, 4, 5, 6. First, what we have to find, what is the probability of each outcome? So probability of 1 is what? 1 by 6. Probability of 2 is what? 1 by 6. Probability of 3 is what? 1 by 6. Similarly, probability of 4 is 1 by 6, 5 is 1 by 6, probability of 6 is 6. Now, next question, what is the probability that the number chosen is an even number? Okay, so first you will have to count how many even numbers are there. 1, 2, 3. So probability of getting even numbers is what? How many numbers are there? Even number 3 out of 6, or you can say half. Okay. Next question is, what is the probability that the number is prime? So first find how many prime numbers are there. 1, 2, 3. So probability of prime number, again 3 by 6 or half. Right, students? Now you will do practice of the remaining exercise.